Previous video we learnt about the modulus of a complex number. Now in this video we are going to learn about the argand's diagram. Now if you want to plot a number, say x equals to 2. Now if you want to plot this number, we need a real axis. Right, this is a real axis. This is say -1, 0, 1, 2, 3. Right, if you want to plot x equals to 2 on this axis, right, you can plot it here. Right, but if you want to plot a complex number, say z equals to x plus iy, or say z1 equals to 2 plus 3i, right, to be exact, I took a complex number, and if you want to plot this complex number, so for that we need two axes. To plot a complex number we need two axes. One, that's the real axis, and the other as the imaginary axis. In the real axis we plot number 1, 2, -1, -2, and so on. In the imaginary axis we plot numbers as 1i, 2i, 3i. Similarly, -1i, -2i, -2 looks a bit silly, -3i. Right, so if we want to plot 2 plus 3i, the real number is here, the real element is 2. Now 2 is here and the imaginary part is 3, so we mark this as the complex number. This is the z with coordinates 2, 3. This represents my complex number, this complex number. And you can take any other complex number, right, and you can take negative numbers, positive complex numbers, and all that. Right, now we are going to understand another concept that's called the polar coordinate system. So now if we say we measure the coordinates of a point by a rectangular Cartesian coordinate system, right, so this is my rectangular Cartesian coordinate system, and we use two axes, x and y. Right, now if we want to measure the coordinates of a point, say we take a point and we have the origin, so we measure its length that corresponds to the x-axis, that's called the x component, and its length that corresponds to the y-axis, and we call the y component, and we represent the particle p or the point p by the coordinates, the x coordinate and the y coordinate. Now apart from this we also have something called the polar coordinates. Well, in the polar coordinates we have that same rectangular axis, but we do not measure the coordinates of the particle. Instead we take the particle, say point P, and we measure the distance of the particle from the origin. So this is the point P and this is the origin, and the distance of the particle from the origin, that is denoted by r. Right, r, we measure the distance from the origin and the angle that this line, the radius, makes with the x-axis. So we draw perpendicular, say A, and we measure the angle theta. Well, angle theta is equal to angle POA. Right, now if you see, then suppose we are given the particles or the points x coordinate and the y coordinate, and we are given the r coordinate and the theta coordinate. Right, so we are given the coordinates r and the angle, right, and we are required to find the rectangular coordinates of the particle, so, or the point. So if we told to find the rectangular coordinates of the point, then r equals to x equals to r cosine theta and y equals to r sine theta. Right, so from this formula we can find out the x and y. Right, now if we are given this x and the y terms, then we can find the r and the theta by the two formulas as x square plus y square equals to r square. Right, now this is a formula. Now we can verify this as, right, we take the value of x and plug it in this equation, and we take the value of y and plug it in the value of y. right? So x is actually r cosine theta whole square plus r sine theta whole square, right? This is actually r square cosine square theta plus r square sine square theta. So this becomes, if we take the r square common, it becomes cosine square theta plus sine square theta. Now if you see, then from trigonometry the value of cosine square theta plus sine square theta is 1. So we get r square. Now see, this is the left hand side, which is equal to the right hand side as r square right hand side. So this formula is proved. So if we are given the x and the y coordinates of the point, say x and y coordinates we are given, then we can find out the radius as r equals to square root of x square plus y square, right? So this is the formula to find the r. So let's say it as equation 1, we need it later. Now again, if you see from the diagram, that we want to find the value of tan theta, the tangent theta, where the tangent theta is the perpendicular divided by the base. So it's the perpendicular divided by the base. So perpendicular is PA divided by OA. So it's actually PA divided by OA. Now PA is the x component of the particle or point, and PA is the y coordinate of the point because it corresponds to a length in the y-axis, and OA is the x component of the particle or the point. So it's actually y by x. Now if tan theta equals to y by x, then we have the value of theta as the inverse tangent of y by x, right? So if tangent theta is equal to y by x, I have space left, okay, leave it. If tangent theta is equal to y by x, then the value of theta, tangent theta is equal to y by x, then the value of theta is y by x. So let's write down the two important formulas that we got, right? If we are given the polar coordinates of a point, then we have from these two equations, then we can find out the x coordinate and the y coordinate of the formula point by this formula, as x coordinate is equal to r cosine theta, y coordinate equals to r sine of theta. Similarly, we can if we are given the x and y coordinate of a particle, say x and y, then we can find out the r coordinate, r and theta, as x square plus y square equals to r square. So we get r square is generally the square root of x square plus y square, right? Now we can also find the theta as tan theta equals to y by x. So theta equals to inverse tangent of y by x. Now what is this inverse tangent? See, suppose we are given a trigonometric ratio and is in a ratio. Now this inverse of this ratio, now it might be a little bit confusing, but if you see, if we find the tangent of an angle, we get a ratio. Now if you find the inverse tangent of a ratio, we get an angle. Now you might see in your calculators there are functions called the inverse tangent. So that's that function is to find the angle, the theta, right? So these two are important equations that we need, this one and this one, right? You need to remember these two equations, and of course these two are also important equations, right? Now if you are not introduced with this polar coordinate system, you can check out my other videos on polar coordinate system. But in this video we are going to learn about the main aim of this video is to learn the amplitude. So I showed the example of a polar coordinate system. So this is the polar coordinate system. Now we are going to draw a complex number plane. That's an Argand's diagram. So this is the real axis and we have the imaginary axis. So this is the real axis, right? This is the imaginary axis. And now what happens, we take a point a complex number. We take the origin, we join the complex number and the origin. Now the distance between the number and the origin, we write it as the r. The angle made by OZ with the real axis is called the theta, and we drop a perpendicular and let's name it as A. Now see, it's almost similar to the graph we had drawn when I was explaining you the polar coordinates. So it's almost the same. Now what is this modulus? The modulus of a complex number, as I said, say this is a complex number, x plus iy. X plus iy is a complex number, right? So x plus iy is a complex number. So the modulus, as I said, is the square root of the squares of the real part plus the square of the imaginary part, right? So this is the modulus. This is the modulus. Now from this figure we can also say that r is equal to square root of x square plus y square, right? I proved it here also. R equals to square root of x square plus y square. This radius is this. So we can say that the modulus of the complex number is just the radius, this r. Now what is this amplitude? Well, as I said, this theta, this the angle that makes, is equal to angle, in this case ZOA. See, ZOA or AOZ, anything. This is the inverse tangent of the y coordinate divided by the x coordinate, or you can write it as the theta only, right, is the inverse tangent of y by x, so the y component by the x component. So now this theta is also called the argand, the argument of z, or it's called the amplitude of z. Now note that I wrote A as capital and A as both the A as capitals. This is because it's important to write, and the reason I'm going to explain in the next video.